Hey everyone, this is lesson 725 from Integrated Math 3 on choosing a tool. So up to this point, we have covered a number of tools to use in solving for missing sides. Here's a little bit of a review of what we've covered so far. Now, the main tools that we have been using are right triangle tools. And traditionally there we start off with Pythagorean theorem, which is our a squared plus b squared equals c squared, or sometimes maybe even leg squared plus leg squared equals to hypotenuse squared. So that's another way of writing it. Then we learn trigonometry, or sine, cosine, tangent, acronym SOHCAHTOA, to help us remember that. So sine, cosine, tangent. And then we learned about special right triangles, 30, 60, 90, 45, 45, 90. Again, this kind of allows us to skip the use of trigonometry and in some cases skip Pythagorean theorem. It's a shortcut. It only works on 30, 60, 90 triangles and 45, 45, 90. So those are two common triangles, so they do come up a lot, which is why it's nice to know that little shortcut for those triangles. Now, those are only for right triangles. You do need a 90-degree angle. And so we had some issues before. We went over a handful of triangles. Here they are at the bottom. So these are the same 8 triangles we looked at before, trying to analyze which ones we knew how to solve and which ones we didn't. So this is where we introduced the new tools, and these are tools we get to use for triangles that don't have right angles, but they actually still could work with triangles that do have 90 degrees. But if you do have a right triangle, then most likely you should probably be using the simpler tools. But for triangles that don't have 90 degrees, these would be your simple tool for those. All right, we are looking at ones that do not have 90 degrees. So I believe, let's see, we have this triangle and this triangle that we talked about, and then maybe even this one. These were the 3 main ones we were discussing before. This one over here is actually called an ambiguous triangle. We didn't cover this this year, but that'll be covered most likely next year. And then these were triangles that not impossible, but that would definitely be a little bit more work to find missing angles. We'd be looking for angles in this one, and then this one there's too many possible answers. So these are the main 3 triangles we're focused on. All right, and assuming all the other ones with right angles, you should be using either Pythagorean theorem, trig, or special right triangles. All right, so today's lesson, I'm going to go over 3 problems, and these are straight from the book. And I actually want you to try to work these out first and see if you could come up with an answer. So I'm going to give you some time to work on this. So I'm going to prompt you for the answer to this problem. See if you could actually calculate this yourself. And then after I prompt you, then I'll go over this the solution. And I'll do that for all 3 problems. So we're only doing 3 problems in this lesson, problem 99, 100, and I think it's 101 from the book. So I'm going to get you started, but for the most part, I want you to try to calculate this on your own. All right, so here's the setup. We are looking at Lake Tofty. A bridge is being designed to connect two towns, one at point A and another at point C. So we have one at point C. All right, so we're trying to connect these two towns. All right, so Lavan has the responsibility of determining the length of the bridge. All right, so we want to know how long does this bridge need to be from A to C. Now, since he cannot accurately measure across the lake, right? He doesn't have the means to measure the distance from A to C. He measures only the distance he can by foot. So he measures the distance from point A to B, because this is on land, and he could actually walk and calculate the distance. So he puts a stake into the ground at point B. So he puts a stake into the ground, right? A little stick. And he finds that the distance from A to B is 684 feet. All right, so let's put that into the picture. So this is going to be 684 feet. So that's 684 feet. And he also uses a protractor to determine that measurement of angle B is 79 degrees. All right, so 79 degrees is angle B. So that's this angle in here. So this is 79. And angle C is 53. All right, so he knows this is 53 degrees. How long does the bridge need to be? All right, so he's trying to figure out, let's put X, right? So this is what we're trying to figure out. So as you can see, there's this triangle in the picture. And so let's actually draw this out. Let me use, okay, so from A to B to C to A, this is a triangle that we're going to be looking at. So let me actually copy this. I'm going to put it over here. So this is really our triangle. I'm going to relabel this. And so we know this is A, B, C. And I'm going to zoom into this for a second. So this is 79 degrees. This was 53 degrees. And this is 684 feet. Right, and we're trying to figure out this one. All right, so your task is to figure out what X is. So really, the main idea is which tool are you going to use? All right, so go through the list of tools that I talked about. I'll give you a hint. There is no right angle in this triangle. So most likely you're going to either be using law of sines or law of cosines. And so I'm going to let you decide and see what you come up with. That'll be the first question. Should we use law of sines or law of cosines? All right. If you said law of sines, you are correct. All right, so now that you know which tool you're going to use, go ahead and see if you could set up this problem and solve for X. We are looking to see a distance in feet, so you will have to eventually use a calculator to get an approximated answer. All right, so I'm going to prompt you for the answer right now, and then I'm going to start going over this. All right, let's see. Hopefully, if you set this up correctly, since we are using law of of sines, you should have, we're going to have two fractions equal to each other. So we're going to have sine of 79 degrees and sine of 53 degrees. I already know the sines go on top, the two angles that we know. And across from 79 is an x. So that means I'm going to put an x at the bottom. And across from 53 degrees is 684. So this is going to be 684. All right, so hopefully this is how you set up your problem. And then at this point, you would cross multiply and solve for x. So let's do that now. So I'm going to be left with x times sine of 53 equals to 684 times sine of 79. All right, then I'm going to divide both sides by sine of 53, which is going to leave us with x equals to 684 times sine of 79 over sine of 53. All right, and hopefully this gives us, so we're looking for the length of AC, which was also x. So this is approximately, this is what the book has, 840.7 feet. So hopefully I didn't say how many decimal places to round it to, but hopefully you always want to have at least one decimal place. Two or I try to, when we deal with measurements, possibly two decimal places if possible. If you round to 841, you would never know if you were really close to, was it 840.9, was it 840.5? Half a foot makes a difference. So you definitely want to be as accurate as possible when you're dealing with measurements. All right, so hopefully, I don't know, did you get this correct? All right, so that's the type of problem we're looking to answer. You'll notice this is a real world situation. Sometimes we need to measure distances that are physically impossible for us to measure. So we deal with measurements that are possible. So in this case, he walked a distance, something on land that he was actually able to measure. And then angles are definitely easy for us to measure using the right tools, protractor. All right, so this is an example of how law of sines could be used. All right, let's go on to the next one. Part 2 to this problem. We're still dealing with Lake Tofty. And so he's not convinced that his measurements from the previous problem are correct. He decides to calculate the distance again between towns A and C using a different method. All right? He wants to verify he did this correctly. So I wonder, is there going to be a difference in our answer? So this time he drives a stake in the ground at point D. All right, so instead of B, he's now at point D. And he is 800 feet from town A. So let me put, we're looking at 800. All right, so a lot further away. And 694 feet from town C. All right, so now we have another measurement, 694. We have two sides now. He also determines angle D is 68 degrees. All right, so now we have an angle measurement, 68 degrees. All right, so now using these measurements, how wide is the lake between points A and C? All right, so does this give us the same answer? All right, so first question really is, which tool are we going to use in this situation? So we have this new triangle. Let me see. Let me take this one. This is going to be our A, D, and C. All right, so here's our new situation. I've taken those measurements, I've redrawn it. Is this going to be, can we use one of our other tools? Something trig related, sine, cosine, tangent. Is it that simple? Can we use Pythagorean theorem? Or do we need to use one of our other tools, law of sines or law of cosines? Well, I'll give you a hint. We're not using law of sines because he says he wants to calculate it a different way. So not only do we have different measurements, but the tool we're going to use is going to be different. So should we use law of cosines or should we use one of our other tools? That's my question to you now. All right. So if you said law of cosines, you would be correct. All right, so we're looking to use law of cosines here. Let me move this over here. So law of cosines. All right, so now that you know what tool you're going to use, let's see if you could set this up. Let me help you with labeling this. Now, law of cosines, we have the letters A, B, and C. Now, you'll notice we have the letter D here. Don't get mixed up with the letters given to us in the problem versus the letters that we use in the law of cosines. So what I'm going to do is I'm going to relabel this. All right, there's nothing that says we can't relabel this, so I'll just get rid of A, D, and C. All right, we don't really care about the letters at this point. We care about making sure we use the law of cosines correctly. All right, so what I'm going to do is I always know that the angle I always want it to be C, and then the other ones I could keep A the same, and then I'll call this B. All right, so which means, and these are capital letters because they're angles, and then so I also want to identify that the side across from A, right, the side across from angle A is usually our lowercase a, and the side across from angle B is always going to be our lowercase b. Right, so B equals to 800. All right. So we do not know what C is, little c, which is that represents the bridge or the distance from the two cities. All right, so knowing that information, then you should be able to set up this problem. All right. And all right, I'm going to give you a minute to set that up. Make sure you look back at the formula for law of cosines and try to plug in those numbers and solve it. Try to have two answers. One, you should have an exact answer that'll have a square root in it. It's a hint. And then you will need an approximated answer. So you'll have to plug that into a calculator so you can compare it with the answer from part 1 about Lake Tofty. Right? We want to know if we're going to get the same answer. All right, so go ahead and do that and then tell me, do we get the same answer or do we get something different? All right, So let's see if you set this up correctly. So I'm gonna write out the formula just as a reminder. So we should have c squared equals to a squared plus b squared. Looks like the Pythagorean theorem. Minus 2 times AB cosine of angle C. All right, so this is the formula we're using. So I'm going to plug in numbers to this. So we don't know C, but we do know this is going to be 694 squared plus 800 squared minus 2 times 694 times 800 times cosine of 68. Well, big numbers. For sure, you're going to be using a calculator for this. All right. So we're looking at, let's multiply these out. So 694 times 694 gives us a huge number. So this is going to be c squared equals to 481, 636. That's a big number. Plus, we're going to add 800 times 800, right, squared. So that's 64. Right, big numbers. Minus, okay, so we're going to go 2 times 694 times 800. Oh my goodness, humongous. So 1110400 times cosine of 68. All right, so for sure we could combine these two. All right, so make sure you're combining those numbers. So that one should be, I think this is, oops, c squared equals 112. This is, let me double check. So 48, oops. We're looking at 481, 636 plus, I think this is it. So 1,121,636. Okay. Minus 1,110,400. All right. Big numbers. And then to get our answer for C, we would have to take the square root of all that. All right, so definitely that's a huge number. This comes out to approximately 840.0 feet. All right. So did we get the exact same answer? Nope. We did not get the same answer from the other one. But we're only a few inches off. So can we say technically, yes, it's the same? Yeah, I think so. So the last time we had 840.7 feet. Now we got 840 feet. 40.7. So 0.7 feet off. It gives us a pretty good idea of the measurement. So if this was the case, probably someone else would do some other measurements. Maybe maybe it wasn't 800 feet, maybe it was 800.3 feet, the distance. So there could be little errors that he made when gathering information. So definitely these would have to be done multiple times to determine accuracy. But for the most part, it looks like both methods give us the same answer. All right. And then the last problem, I don't know if any of you play the piano or keyboard. This is, have you ever seen a grand piano? This is kind of what a grand piano might look like. Usually it has the lid opened up. So if you've ever seen one. So the lid of a grand piano is propped open by a supporting arm, right, as shown in the diagram, in the picture. Carson knows that the supporting arm is 2 feet long and makes a 60-degree angle with the piano. He also knows that the piano lid makes a 23-degree angle with the piano. How wide is the piano? All right, so that's the general problem. And I'll zoom into this so you can see a picture of it. Because for the most part, all you really need to know is the question, and that is, how wide is the piano? So we're looking for this distance. Right, this is the distance we're looking for. So that would be the width of the piano. So if you're not sure how we're setting this one up, let me take still this triangle shape. I think it could be a little bit better. All right, so I'm going to take this. Oops. Let's just make this bigger. All right, so let's look at this. So we have a 23 degrees, we have a 60 degrees. This is 2 feet, and we want to know how many feet this is. All right, there's our problem. So we've just taken a real problem from the piano. We've focused on the triangle, and now the question is, what is x equal to? So let me ask you this. Which tool are we going to use? I'll give you a hint. It's either law of sines or law of cosines. Although there's another approach we could take, that would be a lot more work. But one of the laws would be probably the easiest for us. Which of the two do you think we're going to use? Okay, so if you said law of sines, you would be correct. Now, law of cosines, if you said law of cosines, then I think you're also correct. Right? I think you have options here. Right? So it's up to you on which tool you want to use. And so if you focus on an angle, right? Law of cosine says you need to have an angle and then the two sides. So in that case, we wouldn't really care about 23 degrees. So we have the 2 feet, we have the x, and we have the 60. That's a possibility if you want to use law of cosines. So that's like the previous problem, except the numbers are a lot smaller. And then if you wanted to use law of sines, you need 2 angles for law of sines. But the tricky part here is, one is we know angle 23 and the side across from it, which is 2 feet. If you try using 60, you would be making a mistake because we're not trying to find the length of the lid, right? So if we're trying to find the width of the piano, which is x, we need to know this angle. So then you would have to figure out what's the measurement of that angle first. So if this is 60 and this is 23, then let me ask you this. What's the measurement of the third angle in this triangle? All right, so if you said, I didn't even calculate it. So if you're not sure how to do that, you would take, so all three of those angles should add up to 180, right? So if you take 180, right, 180, and you subtract 60, and you subtract 23, that gives you, let me put this in a different color, this gives us 97. All right, so that's a 97. All right, so if you said 97, you did that correctly. All right, and so the last part would be either you use law of sines or you use law of cosines. I'll let you decide, and then let's see what answer you get. All right, hopefully you were able to do that. I personally would use law of sines on this one. I think it's a lot easier to do. So I would do, I need my fractions, so sine of 97 over x and sine of 60, nope, not 60, 23 over 2. All right, so then that means we're going to have x times sine of 23 equals to 2 times sine of 97. Divide both sides by sine of 23. And x should equal to 2 times sine of 97 over sine of 23. Right, so that would be an exact answer. If we actually want to know the measurements, right? Because it's something that's meaningful for us. So this should be approximately 84.3 inches. No, not, sorry. I'm looking at the wrong problem. Sorry, this is 100. Still, wrong problem. Problem 101. 5.1 feet. Sorry, we're in, units are feet, not inches. All right. So did you get that answer correct? All right, which makes sense. Piano, usually it's looks approximately about 5 feet. So it would be weird if that was like 100 feet. Piano's not going to be that big. It would be weird if it said it was 2 feet. That's definitely not a grand piano. So, all right. This was us practicing using which tool. Hopefully, you were able to do all three of these problems. If not, make sure you have these in your notes. These are good examples of problems that you're most likely you're going to see at least one of these in a test coming up. All right, that's it for now. We'll see you guys next time.